So this is question 16 from section C. So the small research submarine with a volume of 1.2 times 10 to the 5th liters has an internal pressure of 1 atm and an internal temperature of 15 degrees Celsius. If the submarine descends to a depth where the pressure is 150 atm and the temperature is 3 degrees Celsius, what will be the volume of the gas inside be if the hull of the submarine breaks? So for this one, it mentions all of those different variables. So we have pressure, volume, and temperature, which means that we have to find all those volumes. So the first thing we should do is set it up, lay them all out. And go ahead and pull them from the problem. So the first thing it says is that the volume of the submarine initially is 1.5 or 1.2 times 10 to the 5th liters. The pressure is 1.0 atm. And the internal temperature is 15 degrees Celsius. It descends and the pressure is 150 atm, so it is a huge jump in pressure. The temperature is 3 degrees Celsius, and we're looking for that final volume. So the first thing that we have to do, and we have to remember every single time, we have to convert that temperature from Celsius to Kelvin. So we're going to add 273.15 to both of those. So we're going to say 15 plus 273.15. So T1 is now going to be 288.15 Kelvin. And T2 will be 273.15 plus 3. And we'll get 276.15 Kelvin. The next thing we have to do for both of these is we have to check those units, because for pressure and volume, we can plug in any unit that we want to plug in as long as it matches from our initial to our final. So for P1, we see atm. P2 is also atm. Our V1 is liters, and our V2 is unknown. But since we plugged in liters for V1, that means that V2 will be liters as well. Both of our temperatures in Kelvin mean that we're good to go, so let's go ahead and plug everything in. So we start with P1, which is 1.0 atm, times V1, which is 1.2 times 10 to the 5th liters, over T1. Make sure you plug in that Kelvin, 288.15 Kelvin. Plug in all those secondary ones. So P2 is 150 atm. Our V2 is our unknown, and T2 is 276.15 Kelvin. So again, for this one, there's a lot of ways that you can approach it. So let's go ahead and cross multiply. That's going to be a little bit different than normal, but I think cross multiplication might make this a little easier. So we have 288.15 Kelvin multiplied by that 150 atm up top, multiplied by V2, equals, go ahead and do that other side, so 1.0 atm multiplied by 1.2 times 10 to the 5th liters, 276.15 Kelvin. So before we start multiplying and dividing from side to side, let's go ahead and simplify it. So anything that can be multiplied, let's go ahead and do that. So over on the left-hand side, we can multiply together that 288.15 and multiply that by 150. So that is going to be 43222.5 Kelvin times atm multiplied by V2. On the other side, I know that this is a little bit trickier, so we can go ahead and plug it in together. We're going to do 1 times. Since we have a scientific notation, we're going to have to use parentheses. So 1.2, instead of plugging in times 10, we're just going to use that EE button. So if you have one of those black calculators, you're just going to push the key just above the 7. If you have a graphing calculator like this, you're going to press that second key, EE 5. So that's 1.2 times 10 to the 5th, multiplied by 276.15. We get a pretty large number, so it's going to be 33138,000. Make sure you have all of those units, atm times liter times Kelvin. It is a whole lot of units, a whole lot going on. Our last step, so that we can isolate V2, solve for E2, figure out that final volume. Divide both sides by 43222.5 Kelvin ATM. 43222.5 Kelvin ATM. We've now isolated V2. We plug it in, so we say that number divided by 43222.5, and we get 766.68. If you want to know the final unit, you can always look to see what you plugged in. So for volume, we plugged in liters, which means liters is coming out. The other way is we followed through with our units, which meant that ATM canceled top to bottom, Kelvin canceled top to bottom. The only unit left is liters. So our final answer is 766.68 liters.